basically we're here inside the Mips, the Mobile Integrated Profiling System, and we basically have 4 different instruments that look straight up. So any weather that we want to collect data on, it has to move directly over the instrumentation here. We're looking anything from different winds at different heights in the atmosphere, so we're able to sample the change in wind shear, which can dictate how a storm forms and how severe a storm is. Actually, when say a supercell thunderstorm, which is a rotating thunderstorm, or a squall line moves directly over us, we can basically take a look at how hard it's actually raining, how the different size of the raindrops, as well as the up and down vertical motions within that can also give us a clue as to the severity of the storms.
Ron mentioned we have 4 different instruments on the truck here. Each of the computer screens displays live data from each of those instruments. So all the instruments we have on the Mips is continuously collecting data in real time that you can get on the web. And that's what each of the screens here are showing. The first one is basically the wind profile in the atmosphere from the 915 megahertz wind profiler. The second screen here is the temperature and water vapor profiles in the atmosphere from the microwave profiling radiometer. The third screen is actually a screen capture from when the midday QLCS during April 27th moved overhead and showing a high resolution data from the BWIR. And the last one on the end is data showing from the Silometer, showing the current cloud deck above us, essentially.
This right here is a Lidar Silometer, so basically this is shooting a laser straight up, and with the backscatter intensity from that laser, we can actually tell how high a cloud is and how optically thick that cloud is. So if we have very thin, wispy clouds, then a lot more of that laser energy is going to pass through the cloud. If we have very thick storm clouds, then that LiDAR energy is going to stop very, very quickly. And so we can get an idea about how thick and how high the clouds are here.
This van here actually is what used to pull the big trailer we just saw, but now we use it actually for our mobile sounding team. So whenever we deploy all of our instruments out for severe weather or boundary layer studies, we actually typically will release a balloon sounding, and this is the van that houses all of our balloons, our instruments, and also the helium tanks. On top of the van here, we have the standard array of meteorological surface measurements. We get temperature, wind speed, wind direction, pressure, dew point, all of that stuff that you typically get at a METAR ASOS site, for example. In the back here is where we actually house all of our helium tanks, the hose that connects to the helium tanks, the actual instrument pack that goes on the balloons. When we release the balloon, we actually tie this with a string, and it hangs below the balloon itself. We have the actual weather balloon that we fill up with the helium, and then a parachute for when the balloon gets all the way to the top of the atmosphere. The balloon will expand so large that it'll eventually pop. Well, our instrument pack will actually fall, so we have to attach a parachute to it so that it falls slowly in case we don't really know where it's going to land when it does land.
This is MAX. This is the Mobile Alabama X-band radar. And what this is a dual polometric radar. And what dual pole radars do is they actually send out a beam in the horizontal, and then they send out a beam in the vertical.
This is M3V. That stands for the Mobile Meteorological Measurement Vehicle. This is a car where if you think about us going out, say, storm chasing, this will typically be the thing we go out to chase in. At the top it has the typical array of surface meteorological measurements, temperature, wind speed, wind direction, pressure. It also has a compass and GPS so that we know exactly where we are and where we're going. And we can actually, as the car's moving, it can actually take the wind speed as we're moving, and the compass and GPS will subtract out the car's motion to get the true actual wind speed.